Welcome or welcome. Are there any English-speaking people in the room? Ah, awesome. Oh, two, so we're not alone. So I want to ask you guys actually to come a bit closer because we're now sitting all out and that's not going to work for my presentation, unfortunately, because I want you guys to share knowledge as well. So I would ask you guys to come a little bit closer, like especially over here. Just, come to the front row so we can hear each other, interact. I can see you guys. Cool. Much appreciated. Yes, yes, yes. So you have to realize when you're going to submit a talk like this, you always have to sort of find the right words. And the guy who picked me, Willem over here, he told me that he picked the different talks, and you're going to choose some specific names in that title. You're going to choose some specific words in the abstract. And the reason for that is because you want to be catchy. The thing I'm not going to talk about today is ML.NET. You can ask me a lot about ML.NET, but I'm not going to talk about it. If you want to leave, go ahead. The thing I'm not going to talk about today much about is cognitive services. I will do a short demo with cognitive services, but I'm not so much going to talk about that part. I'm going to talk about architecting for AI, architecting for ML, architecting for whatever you want to do. And that's a good thing about architecture. It's technology unaware, if you do it right, at least. So that is the piece I'm going to talk about. So this could have been called Architecting for AI, but since this was a sort of Microsoft conference, I was going to use the right words, and it was going to be ML.NET and going to be cognitive services. Before we're going to do some awesome talk about architecture, I would like to know you guys, but I want to do it in a little bit of a different way. I want to ask you all a question, a very simple one, and that is, what have you learned today? And before you're going to answer that to me, I would ask you to look right and left and choose a buddy and exchange with this guy, preferably standing up, what you have learned today and what was the most exciting thing. So everybody get some energy in this room and stand up and talk to the guy next to you, left or right. Can you guys please sit down again? I just learned something about you guys, and you guys are all fantastic because you actually work with me, collaborate, and actually do talk about the stuff you learned today. And that's, I think, is one of the most important things about all of these new technology, which comes in an enormous speed at us. We have to talk about it. And that's the reason why I'm here, but also why you guys are here. And it's just awesome to see. It's also to see that I actually saw people with sometimes 3 or 4 chairs in between that they are still connecting. So what I learned about you guys is that you guys are awesome. I just want to check 2 things with you guys before I continue and tell something about me. First of all, who has contributed some code this week? like committed into Git or source control, whatever, yeah? Have anybody of you guys has also fixed some unit tests? Ah, that's good, that's good. And what about anybody of you guys have built some models? Some AI models recently? Okay, you guy, what's your name? Sven. Okay, Sven, what is the, have you done any education in math?
Not really.
Not really, so why the hell in the world did you start building a model then?
It was kind of a hobby project and part of a proof of concept to build a regression model actually using ML.NET, an older version than the most recent one, just to see how it works and if we could possibly do something like that in the near future.
Okay. So hobby, just figuring stuff out. Awesome. Great. Great. Take an example. This guy's awesome. Well, but you also have learned probably that it's very hard to build one.
Yeah, you really need to know what you're doing and where you're getting yourself into before actually starting your project. It was kind of a deep dive.
I hear some fantastic things like starting project, thinking about it, hard, etc. That's sort of the thing we are running at. I want to dive straight into some future stuff about AI architecture, yada, yada, yada. First, I want to talk a little moment about myself. I'm Alex, 32 years old, male. This is, by the way, really easy, really hard to do. I'm working at the current moment for a health tech company. And how do you visualize a person with a gender unknown? Do you put a question mark? Do you put an asterisk or anything like that? Just think about it. It's a hard problem to solve. You cannot find AI for that. I live in Rosmalen. Basketball, tennis, stand-up paddle, that's sort of cool. This is not my son. This is actually my nephew. He looks quite a lot like me, the way how I was when I was younger. So that's cool. I love jazz music, wine, and Lego. That's sort of the thing. And why you should believe me today, that's because I'm a technology coach at Expert. We can choose our own titles over there. And this fits me the best. Because I try to coach people to try new technology, think about technology, and do new stuff. I mainly focus on product companies. That doesn't mean that I'm not available for other companies, but I mainly focus on product companies. The reason for that is because they make a choice, and they have to stick with it for 5 to 15 years. And I like that thing, so you have to really think through it, and have to make sure that you have make the right decision, or that you make a decision which you can revert at a later point. So that's me, and now let's get to artificial intelligence. But before I get there, I have to tell you guys what my reality is about artificial intelligence. What is this? The enterprise. And that's also the place where I'm working most of the time. I'm working in the enterprise. I'm not working for Netflix. I'm not working for Microsoft. I'm not working for Google. So that means that everything I do has to be practical. I need to have a reason why I do stuff. And that's important. I'm not sure if anybody over here works at Netflix, Uber, Microsoft. Is there anybody over here? Is there anybody who works in hyperscale companies, Spotify? No. So that means for you guys, it's the same story. You guys really have to do something. You know, if you do something with AI, it has to add value. Unless it's a hobby project, of course. So the primary, probably most easiest way to think about AI is what we see these days on our smartphones. And that's, for example, this one. You see here, speech recognition. And I got a small demo for that. We're talking about cognitive services. So let me start up that demo over here. You can just actually download this from the Microsoft site, and it's up to date, it works, and all of that stuff. You know, you can straight away experience it. The only thing you need to do is you need to fill in 2 keys. I will show that in a second. And if I enable my microphone, I can actually talk now afterwards to my computer, and then once I stop, whoo, and then now I don't have an internet connection. Gosh. So the general idea would have been that I was speaking to my computer and that it would then recognize it, and then it would show it over here. And all I basically need to do for that is, in this application, I would need to do something like media capturing. That's sort of straightforward stuff. Then I need to make a key in the Azure portal. I need to tell it where it is for some reason. I don't know why they cannot figure that out for me. And then I just send that data somehow to it, and then I get some response, and then it says recognize text. So that's the thing. Let me be very clear about this. This is the dumbest example of AI I know. Microsoft has released a set of these services, and they are awesome. But if we look at this, this is pretty dumb, because I have no other possibility to go around this. Let's assume that this was the input for me for a business process, and I don't have an internet connection, then I'm screwed. So this is actually one of the dumbest things you can do with AI. You have to think way further than that before you can actually do something which makes sense. So, let me go back to my slide deck and let me explain it. If we look at AI in the enterprise these days, there's only two real use cases. We want to enhance the user experience with some additional capabilities. We all know this from WhatsApp or from any of the other cell phones, where you guys probably cannot see it if I do it like here, but if you these days there's this small icon. This is really funny, 30 guys watching at a 30 by 30 pixel icon. But there's this small icon, and then I can talk to WhatsApp. But I can still enter it in the text box next to it. So I have an option. So that's the first part of the user experience. And then the second part, it's there. What you can do is you can improve business decision making. So you could forecast or something like that. But in order to do that, you need to have a lot of things on your mind. And the last few months, or actually the last year, I've been working with different customers who had the same challenges. And that I was going to talk about. That is what I'm going to talk about. My experience report for that piece. So before I'm going to continue, grab some water. So the first part, enhancing user experience. What comes to my mind straight on is, okay, so I do want to do some speech recognition. Is my AI always available? That's sort of a hard thing, like, okay, we see all of these shiny demos with internet connections and all of that stuff, and now out of a sudden, I have this guy who is actually traveling, and a business guy, he's in sales, and I want him to make his offer with notes. He's talking in his car, driving, and he's saying, I just spoke to this customer, and he wants to order 5 products. Maybe I want to enable that scenario, but hey, I'm offline. F-U-C-K, something like that. Then you have some other considerations, like, is your model fast? Is your model reliable? So every time then when I say to my model, I want to do an order for 5 products, will it also recognize 5? Sometimes it will recognize 4. And then you have to think about, is that reliability, is that not a very important aspect of using AI? Because AI, by definition, is not an exact science. A few of the other speakers were talking about that. So maybe I should consider for what sort of problems I should actually be using AI. And hey, wait, if I'm gonna be guessing now, well, then I don't want to use AI. If I know precisely what's going to happen, so if this person hits 5 on his keyboard, like that, I don't have to, I don't have to send it into AI. So there are certain moments only when I want to use it, and I want to use this reliability, knowing that I only will be between 60 and 90% correct with an AI model. So these are all considerations. So when it comes to user experience, I have a few simple rules which I learned there. First of all, don't let AI become the reason why your user bounces. I see people coming to websites which are completely, bless you by the way, who are completely built by AI, and users don't get it and they bounce. They are just gone. Why is this recommendation here? I never ordered this. Bye. That happens. If you do that with a business application somebody has to use every day, then they will come back to your desk and say, hey, you screwed up that new design. I want the old version back. Happens all the time. So one of the simple things to do there is always offer fallbacks. So make sure that if you are going to enhance user interface, offer fallbacks. Also realize that if AI becomes part of your validation process, offer a suggestion or offer an alternative. You see Google here using AI, image recognition over here, and they actually allow you to also listen. So they offer you this fallback. They even will call you at the moment that it doesn't work. Also verify there, and I mean this is more UX design than anything else, but that is actually part of architecture. So in that sense makes sense. But also consider if AI actually makes sense and if it actually shortens the route to the desired action. Because it's very nice for you to click on these sort of things, but I can tell you that the old CAPTCHAs were way quicker. And I hate these new ones by Google, because for some reason I'm always the bot. I don't know why, but I just keep on clicking. That's the thing. Also realize when you start doing AI, it's important that you want to use like well-known paradigms. You want to bring that to the world. So icons are very helpful there. Microsoft has done a fantastic job on this website. I don't know who of you has been doing. Well, just whatever. Who of you guys have been doing Universal Windows programming? But they have this fantastic icon set. That's one of the things they do very well there. And they have a microphone, they have a camera. These are well recognizable things. And you guys are, he's talking about UX, we were talking about architecture, we want to talk about technical stuff. I understand. But this is probably the thing where you can prevent yourself from having to code just by thinking a little bit up front. Just remember with user interfaces, there's only one chance to do it right. And then we're going to talk about architecture and about boxes, etc. Who of you guys knows the MVVM pattern? Yeah, that's like a majority. That's good. So basically, if you do desktop development, this is one of the most popular patterns. And they basically say you have a model, which is sort of your reality. And that's, for example, I have a salesman and I have an offer, and I might have stuff like products, and that's the sort of classes and entities which are living here. Then I have some presentation over here. This could be my XAML, this could be my HTML or similar things. And then I want to bind that together. And typically what I'm going to do is I'm going to put all sorts of user logic into my model. It's like very easy. So at the moment there were a few wise guys and they said something about separation of concern. And they said, okay, if you want to separate your concern, then you want to have something in between. And that's the view model. So you still have your pure model, which contains all of your business logic and all of your business data. The view model helps basically the view to represent the model in a good way. If you think about this separation of concerns, what's going to happen in AI is you're going to enhance this view part with some new features. For example, the button to click on a microphone and then speak to the system, and then it will be sent back. So afterwards, that means that you put in your AI interaction over here, but this part is still there, and this part will be responsible for something very simple, actually. First of all, it will probably be responsible for the real interaction with that model. So it will go in there. So it will actually talk straight on to the web service or to the local model. And secondly, it will most likely, it will also do the validation, because you might get some invalid input from this sales guy who's actually talking to the view. So how would that look? Well, on my view, I have a microphone button. And at the moment that I click on that, on my view, I'm still over there talking to my view. At the moment that my sentence is finished, it will be sent to the view model. The view model will send this sentence to the cognitive service. It will receive it back. It will validate the outcome. And finally, for example, request the model to update it with 12 products. As simple as that. Now, if we are going to look at it from another perspective, for example, from the web perspective, we're seeing these days that we see a lot of model view controllers. MVC, have anybody worked with ASP.NET over here? Yeah, a few guys. So you guys have probably worked with the MVC pattern. So in the MVC pattern, it's a little bit the way around. In the MVC pattern, you actually see that you still have that button over here, but the user sends at a certain moment the input, but it will not send it to the view model. It will basically send it to the controller. And the controller is there also, similar to the view model, responsible for talking to that model, says, okay, let me grab the right details out of that sentence, validate that, and afterwards update the model. That's relatively simple, right? Is this all straightforward? Okay. Happy to hear that. So that basically means that if you want to use these, if you're going to use a desktop application or a web application, it's very straightforward. If you want to add some user experience, if that's the use case, you're going to add it to the front end of your system. You're going to add it to the view, and you're going to make sure that your business logic is AI unaware. The second part is you're going to make sure that the view is not having any problems with, is not going to have any, or is going to have a fallback for your input. Cool. So that's that. That's UI, straightforward. Then if we think about driving decision making, we heard some keynotes about possibilities with AI replacing faces and all of that sort of stuff, and that's awesome. But in reality, we're still going to have that sales team who wants to predict next week that they're going to, what is their forecast going to be? They're going to think about what is the right moment to reach out to this customer. And all of these sort of use cases, this is a very nice place to basically drive decision making. If you look at it for sales, you can talk about forecast. If you look at marketing, you can talk about retargeting. You can talk about advertising, etc. If you talk about operations, we know operations in several ways. You can have manufacturing, you can have healthcare where you have real diagnosis and those sort of things. So that's what I call operations. And typically what you do is you want to consult what's ongoing and you want to do some failure analysis. And these are all parts where you can have your AI help you. But you have an existing application. So how are you going to do that? Has anybody here heard of the concept of ports and adapters? Ah, I see a name. Okay. Who over here is aware of the concept of interfaces? Ah, that's good. That's good. Who over here does know the concept of data providers? Data providers. Okay. So, if you think about AI, let's assume that we predict next month's income. It's a very simple example. How would we want to do that? Let me do some poor man's coding. It's always fun. So we're probably going to have such a thing as a public class. I want to make this a little bit bigger so that everybody can see it. We're probably going to have. It's always fun to type on something like this. So we're gonna have a class which is called sales status. Sales status, and probably this sales status is gonna have like something like a public enumerable of month results, which is past results. And of course, you cannot edit that. That's coming from somewhere. You're probably also going to have something like sales. You're probably also going to have something like the forecast. Oh, don't need it. And then month result is probably a small class which you're going to. That's a small class with public class like that. Which is probably going to have something like, it's going to have a month, and it's probably also going to have, like a number. Let's do it as simple as that. Then, of course, if we're going to have a method at a certain moment which says such a thing as sales status, public sales status, get sales status. The first thing it's going to do, it's probably going to fetch the past results, because that's easy. I mean, this is in essence is going to be nothing more than a database query. This is easy. But then you're going to predict that the next stuff as well. And this is where it gets interesting, because of course here is the place where you want to use your AI model. So what we're going to do in this case is we're going to build something like extremely simple to show you the idea of this. We're probably going to get an public interface of get forecast. Sorry. I need intention revealing interfaces, forecasts, calculator. And this wants to get the forecast, and it probably wants to do that in an easy way. It probably wants to do something like, it want to get this. And it's probably going to want to have the past results. And we probably want to get because we're doing .NET, so we want to add an I. What we want to do is we actually just want to have an I forecast calculator. Something like this. And then we want to, set, or we want to do a new sales status. And we want to put some past results, a forecast we want to put it in. And of course you want to return this and correct me for doing it wrong. Thing. And then of course this is probably gonna be something like, oops, this is gonna be like calculator. This is very clear code, isn't it? So if I'm talking about ports and adapters, all I'm basically talking about, okay, we're having inside our business logic, we over here have this sales status thing. This happens here. But what we want to do is we want to move our artificial intelligence calculation. We want to move this. We call this an adapter. The interface we just saw, which I called I forecast calculator, is a port. Why do I want to do that? Why do I want to get my AI calculator outside of it? Well, every time that I do an AI calculation, I need to have a lot of CPU, I need to have data, and all of that sort of stuff. So I don't want to execute this on runtime. So what I do instead, I basically tell that execution of my AI model happens outside of my model. And that very much simplifies this entire thing, because what I'm gonna see is, okay, I'm now calculating it, but I can also create extremely easy. I can also create a second class, which I want to use potentially for unit testing. And that second class for unit testing is probably going to be something like of course, this will not compile. So what we're going to do is we're going to move this one to my method as an input here. And we're just going to ignore this piece. Then I can just move this in. But it's, in essence, what I'm saying here is your AI model in this model is not part of your business logic. It's moving out. It's moving to an infrastructural piece of your code. And if you do that, you can actually build your business logic and you can still depend on an AI model at a later moment. Wow, this is quite a lot for 4 o'clock, isn't it? Is it still okay? Still doable, this? Okay, cool. Good. So this is. I'm moving AI models out. Okay. Basically, you guys have heard me all talking about models. Not about these models, but at least about models. So where are all these models about? I still find this a little bit weird. You know, somehow this sort of gives mixed feelings, sort of for me. It's perfectly symmetric, but it's still weird. A weird lady. But hey, yeah, this is just my honest opinion. But hey, let's think about these models for a moment. What do you want to do with a model? You want to build it, you want to buy it, or integrate? Buy. That's what I was expecting after. No. So we are developers, and the first thing we do at the moment that we see new technology, we jump at it. We got some pet projects ongoing. Sorry, I have to. We've got some pet projects, so we're going to build it. We're going to build it. But it's actually quite dumb to do that, because building good models is, especially for a business context, is a job in itself. I'm not sure if there's anybody over here who's a data scientist. Okay. So you're probably the only guy over here who can talk about whether, in what circumstances a model really works, when it doesn't work. You can reason about that. You can explain your customer with what data you can train this model, etc., so it makes sense in their context and those sort of things. The average developer, when he's hearing about this, is like, wow, this is complicated stuff. And it is, yes, it is. So data science is a profession. So what I recommend for everybody is to at least consider, for every company who starts with AI, to at least consider these 3 questions. Do I want to build it myself and acquire all of the knowledge? Do I want to buy a model? Maybe there's a model zoo which I can just, download it, or maybe I can download it for, 1,000 euro, or can I integrate with something? And the last part becomes more and more appealing. Especially if you look at cognitive services, you see the possibility to integrate actually with models which you can train yourself, so you can supply the sample data, it will give you back a model, and you can run it in your application without a problem. So especially these considerations, these things are important. You will see that the next phase of startups is going to be AI model startups, where you can integrate with. In the healthcare, at the current moment, if you are specialized in cancer treatments, they want to integrate with you because they want to send you anonymized patient data. This company, this startup, will train its model and will give it back to the hospital, and the hospital will use that particular model. Because the hospital knows that they cannot build models themselves. They cannot acquire that knowledge. So this is a very vital question to ask yourself. Build, buy, or integrate. You have to do that actually every day, but especially with artificial intelligence. Then I was talking about models and grabbing that and pushing it back. And for those who have seen other talks, they probably also have heard about ONNX. And ONNX is the future of everything. It's really cool. Microsoft, NVIDIA, AWS, and a few other parties have collaborated together, and they basically have made it an XML format, which they then have proto-buffed and whatever. And then they made a very weird thing out of it, and that's now a model. And basically, that's a trained model, which you can download and you can put on your disk. You can build it with any framework. ML.NET, you can build it with MX, you can do it with TensorFlow, whatever, and then you can just deploy it. I will come back to deployment soon. That's really cool. You can even use web interfaces, for example, to make a custom ONNX model using custom vision. Very cool. So basically, model interoperability is solved. Every vendor out there, claim, every vendor out there who doesn't support ONNX is going to go out of business pretty soon. There's only one issue with ONNX. It is interpreted on top of hardware, so it's not that quick yet. But luckily, there are some great initiatives on that area. One of them being the ONNX runtime, which is basically a smart runtime, which is made by Microsoft and open sourced. And this ONNX runtime basically lets you run every piece of every model in whatever way you want to do it. There are other examples of it. MX.NET has a model server, and you also have Azure Machine Learning where you can do it, where you can run it as well. The problem with that last one is it's extremely complicated, overly, but I will show you that in a minute. I just want to show you guys how do I do this ONNX runtime in some code I've written myself, so not code I've inherited. Here we go. Is this readable for everybody? Okay. So I got somewhere a model. And this model, this is actually over here on my desktop here. This is the model. You guys want to see the model? That's awesome. The model, I can open this model actually with Neutron. Neutron is built by a guy, maybe you know him, Alex de Groot. He has built in the past Reflector. So you could open .NET DLLs with it. But this is actually the model. This is the ONNX model. It's a little bit large, though. So you can look at it, you can click on it, you can get some details about it, etc. These files are relatively large. So this one is 34 megabytes, but I also have another one over here that's ONNX2. This one is over here is 250 megabytes. So these are trained models, and I just can get them from the internet. Awesome. That's so I'm including one. I've got some sample data, and in this case, I want to get the idea about some of the pictures. What is their emotion? I will show you the picture. That's very simple. I used some sample data with one of my very good friends out here. It's really small because if I do it with too much memory, then it's like, then it starts to get too much computation. And here I got myself as well. I got my girlfriend in between. She's probably very happy that I do this. So no, never mind. Cool. So that code. So what we're going to do, I'm going to run you guys quickly through it. I get some input details, which I will show. Then I show some output details. This is the input detail of the model, and then the output details of the model. Then I will go through my files. And what I will do is I will reformat my files. I will extract the pixels from it, put it in a very long array, which they call tensor. Weird guys, those data scientists, sorry. And then I will just calculate the output, basically. I will evaluate my model, and then I will finally do my output. So first of all, I get my input. This was my model. I have an input 3 that has 4 dimensions. It's a tensor, and it's of the type single, which is also known as short or whatever. Then we have output type. It's not short, it's float, isn't it? It's float, yeah, sorry about that. Then I have the output type, which is really weirdly named, but that's because it's built with TensorFlow. It has only 2 dimensions, and it's once more a tensor, and it's also a float. What I do then is I process this for my file, and I finally get a score per category if I'm happy, not happy, or anything like that. And in this case, you actually see there that fear is quite high, and neutral is also quite high. So this is really a well-trained model, I'm sure. You see the same thing happening for for my girlfriend. You see over there that she has a little bit of a different neutral, but she's also surprised, and she's also having a bit of fear. And then also last part, the thing, we have here Levon, and Levon, I think Levon is also surprised a bit, which the other ones aren't. This is interesting though, because these numbers are fairly close to each other. And it turns out to be that this is one of these examples where you see that this sort of stuff is real hard to work with. Because what's happening actually is I don't get something straightforward back. I get my result variable, which I need to get back as a tensor, and then I need to do something which is called execute softmax. And what it basically means is because they are throwing over all sorts of figures, in the end of the story, you want to do what they call a softmax, and basically you want to move this number back between 1 and 0, and that should be your score. And even though this works perfectly in Python, for some reason it doesn't work well in C#. So I still haven't figured out what is ongoing, but this is one of the reasons why you should really carefully consider, you know, like, okay, I need to do a lot of math and those sort of things. I need to understand how these models are working very well. So I really need to think, should I really build it myself? Because it actually requires a lot of additional knowledge, which I'm not really aware of. Going back to my slide deck, what I just did, the code you saw, this is using the ONX runtime. It's updated by Microsoft, and ONX has an IR version, which is the version of the model, and then it has an offset. So basically it says that it allows you to run, for example, ONX 1.4, and then the offset is, I think, is 9 at the current moment. Those are two different numbers. So when you get a model, just realize that these are two important numbers to verify if you can run it. Other possibilities to run such an obtained model is the MXNet model server. You can find it on AWS in a very fantastic way easier than Azure does it. Sorry about that, Microsoft, third time. Then you have the Azure machine learning way, which is an extremely complex way of doing that. They basically require you to write some Python and that sort of stuff. Good. So we've spoken about running the model. We've spoken about where to put it in your architecture. Then we have the last part, which is sort of really important, and that is the deployment considerations. And if I've done that, I'm probably at the end of my, not at the end of my talk, but I got way more. Then we probably have to open up for questions. There are two considerations you want to have. You either want to run your model locally with your application, or you want to run it remotely. And that's basically based on a few criteria. First, you want to figure out if your model is evaluating in a stable way. Is it like, you know, is your evaluation time stable? For example, is it something like, does it take like 1 minute always, or does it always take 10 seconds or 10 milliseconds? And is that a sort of a stable thing? If not, it's probably a good thing to deploy it remote. Because because then you can probably do some hardware acceleration externally, which you cannot do in a local computer. A second thing is, if you can use local hardware acceleration, then it's probably a good idea to deploy it locally. While if you don't have any local hardware acceleration available, then remote deployment is probably a good idea. Then the last part is latency. Consider latency. When latency is a problem, for example, when you have a sensor which needs to have an own model somewhere locally, somewhere, you know, next to a road without an internet connection, you probably want to deploy it locally rather than that you wanted to wait for a remote call elsewhere. So those are the things which you wanna consider. And then a good example, and that's what I see often if you have an intranet or something like that. You know, if you can control that network, why wouldn't you deploy it remote? You don't have the issues with deploying it to every local machine at those moments. Good. I got actually way more than just this, because I was also going to talk about building and hosting the models in the cloud. but I also see already some small eyes over here. So I kind of think that I'm going to move it to an end. I'm just looking at the back at Willem. 1 minute. So that means that I'm going to do something else. I'm gonna go really quickly to my key takeaways. So what I just want to say is use your existing architecture to loosely integrate with AI. Don't bind yourself in your architecture really on your model. Consider really well if you should build your AI functionality yourself. Build on top of the shoulders of giants. You know, like Microsoft, Apple, Google, etc. They will allow you to buy very good models in the future. Deployment of your model is a key consideration of your success. That's the thing. Use open standard. And then the last piece, I didn't get to it, but especially building these deployment pipelines, like getting your data from, especially on-premise, towards, you know, like getting it online, training your model, building it, hosting it, optimizing it, etc. That's an extremely complex thing and is key for disaster. So if you don't have to do that, if you can obtain that, think about build, buy, or integrate, obtain it, because it's a quest in itself. Sorry for the data scientists, but that's really my experience so far. Boom, questions. That was a bit much, was it?
In your model view, you did put your AI into the view. Why?
So I didn't put the AI necessarily into the view, but what I think is, especially for example the recording and those sort of things, I would put that definitely into the view, and then I would actually evaluate it from the view model. That's what I said. So, but putting it into the view, purely into the view, would be a little bit of a weird thing to do, yeah. That's other questions. Beer? Thank you very much. If you have questions, I will be around a bit. You can also find me on Twitter and anything like that. And have an awesome evening. Thank you.